What you are about to see is not incremental improvement. This is a complete reimagining of how the world processes stranded gas. The Cascade gas fractionation system, combined with the integrated carbon-managed energy platform ICMEP, is the most advanced, most efficient, and most profitable stranded gas processing technology ever assembled into a single integrated platform. For the first time in history, every molecule, every BTU of heat, every ton of carbon dioxide, and even the moisture in the air itself, is captured, converted, and sold. This is not the future. This is available right now. And it changes everything. Right now, across the globe, stranded gas operators are burning billions of dollars worth of value in flare stacks. Carbon dioxide is vented into the atmosphere. Waste heat disappears into the sky. Ethane, propane, butane, premium petrochemical feedstocks are sold at commodity prices or simply wasted. The industry has accepted this as the cost of doing business. We refuse to accept it. The ICMEP platform was engineered from first principles to eliminate every source of waste in the stranded gas value chain. Every byproduct becomes a product. Every waste stream becomes a revenue stream. This is the breakthrough the energy industry has been waiting for. The process begins with a groundbreaking pretreatment train that sets a new standard for feed gas conditioning. Raw wellhead gas, carrying slugs, sour components, water, and mercury, is transformed into ultra-clean specification gas in a single integrated step. A high-efficiency slug catcher removes free liquids. A proprietary amine treating system strips every trace of hydrogen sulfide and carbon dioxide. Triethylene glycol dehydration dries the gas to below 7 pounds per million cubic feet. And a dual-bed molecular sieve system delivers the deepest possible moisture removal, protecting every downstream cryogenic component. What enters as raw, dirty wellhead gas exits as pristine, pipeline-quality feed, ready for the cascade. Here is the technological heart of the system, and it is unlike anything the industry has seen before. The Cascade condensation fractionation train is fundamentally different from conventional plants. Rather than chilling the entire gas stream with deep refrigeration, the Cascade uses precisely controlled operating pressures at each heat exchanger stage to selectively condense each hydrocarbon fraction at practical, above freezing conditions. In the first stage, HX201 operates at around 250 pounds per square inch. At this elevated pressure, the heavy condensates, pentane and heavier, drop out at near ambient temperatures around 60 degrees Fahrenheit. No refrigeration required. The second stage, HX202, reduces pressure to approximately 120 psi, causing butane and isobutane to condense at around 50 degrees Fahrenheit. In HX203, pressure drops to around 60 psi, where propane reaches its dew point and is recovered at approximately 30 to 40 degrees Fahrenheit, a temperature easily achieved with standard glycol water cooling. The final stage, HX204, completes ethane recovery at lower pressure with moderate cooling in the 20 to 30 degree Fahrenheit range. Every stage operates well above the extreme sub-zero temperatures used in conventional cryogenic plants. Each stage is optimized for pressure-temperature equilibrium, recovering 22,400 barrels per day of NGL with minimum energy input. This pressure cascade approach is the engineering breakthrough that makes ICMEP dramatically more energy efficient than conventional fractionation. The condensed NGL streams recovered from each cascade stage are routed through a high-efficiency separation and conditioning system. Because the cascade already separates hydrocarbon fractions by pressure and temperature, each product stream arrives at the fractionation section already partially segregated. The system does not rely on conventional dethanizer or depropanizer distillation columns. Instead, the pressure differential separation achieved in each heat exchanger stage delivers each hydrocarbon fraction at the purity and composition needed for direct product conditioning and storage. High-efficiency coalescing filters and separators remove any remaining entrained liquids and ensure every product meets pipeline or sales specification. The result is 4 distinct product streams: ethane-rich gas, propane, butane, and stabilized condensate, each directed to its own storage and sales pathway. Where conventional plants produce one blended NGL stream, the ICMEP Cascade delivers 4 individually optimized products, each sold into its highest value market, representing a 20 to 30% revenue premium over conventional processing. Here is the engineering insight that changes everything. You might expect a system that separates hydrocarbons at temperatures down to -60 degrees Celsius to require massive, exotic cryogenic refrigeration machinery. It does not. Almost all of the thermal energy needed to drive the entire cascade comes from 2 of the most proven, widely available technologies on Earth: cooling towers and ice banks. Cooling towers are already installed all over the world, cooling large office buildings, hospitals, data centers, and factories. They are engineered for enormous rates of heat transfer. They are reliable, locally serviceable, and available on every continent. The ice bank system charges overnight using low-cost off-peak electricity, building a thermal reserve that discharges during processing hours to handle peak cooling loads across the heat exchanger train. Together, these 2 systems deliver the sustained, precisely controlled cooling that drives pentane, butane, propane, and ethane condensation through each pressure stage. No exotic cryogenic compressors. No specialized refrigeration machinery requiring factory-trained technicians. The same technology keeping your office building comfortable is powering a multi-billion-dollar gas processing platform. That is not a compromise. That is genius engineering. This is where the ICMEP platform makes history. 200 megawatts of clean electricity, generated without burning a single molecule of fuel. The Carbon Managed Energy Recovery Center uses solid oxide fuel cells, the most advanced power generation technology ever deployed at industrial scale, to electrochemically convert methane directly to electricity at temperatures between 700 and 900 degrees Celsius. 170 megawatts of DC power flows from the fuel cell arrays. The high-temperature exhaust then drives an organic Rankine cycle system, extracting an additional 30 megawatts from what would otherwise be waste heat. 200 megawatts total. No flames. No combustion. No NOx emissions. Just clean, carbon-managed electricity, enough to power 150,000 homes, while simultaneously capturing the carbon dioxide for sequestration or utilization. Here is where the ICMEP platform does something no conventional plant has ever done. The methane-rich off-gases that other plants flare or vent, we convert them into premium gasoline. No crude oil. No petroleum refinery. No barrels. The methane off-gas stream is first converted to synthesis gas, a mixture of carbon monoxide and hydrogen, in a compact reformer unit. That synthesis gas then feeds the methanol synthesis reactor, where it reacts over a copper-zinc alumina catalyst at 250 degrees Celsius to produce high-purity methanol. The methanol then enters the zeolite catalytic reactor, using the proven mobile methanol to gasoline process, where it is converted directly into specification-grade gasoline. 2,500 gallons per day of RON 87 plus gasoline. Produced entirely from gas that would otherwise be wasted. This is not a refinery. This is a gas-to-gasoline conversion platform, and it produces transportation fuel without a single barrel of crude oil. Carbon dioxide from the SOFC exhaust and amine system is also captured, 500,000 pounds per hour, compressed and sold as verified carbon credits. This is not carbon capture, this is carbon monetization. Now let's talk about what this breakthrough means in financial terms. 1 inlet pipe. 1 raw gas source. 7 simultaneous, independent revenue streams. LNG sales generate $150 million per year, from the same gas that once went directly to pipeline at commodity prices. NGL products, ethane, propane, butane, condensate, add 120 million. 200 megawatts of clean power contribute 70 million annually. Carbon credits and CO2 services deliver $50 million, turning an environmental liability into a profit center. Gas-to-gasoline conversion, methane off-gas converted to premium fuel, adds 45 million in transportation fuel revenue. The atmospheric water generation system, producing potable water from air moisture, generates $35 million in water-scarce markets. And industrial gas sales round out the portfolio at nearly 18 million. Total, $542.8 million per year. From gas. From heat. From carbon. From air. This is the ICMEP revolution. Here is something no other gas processing platform on Earth can claim. The ICMEP system requires 0 outside water sources. None. The process generates and harvests all of the water it needs entirely on site. The atmosphere around us contains an enormous reserve of moisture. At a full-scale ICMEP installation, approximately 35 million gallons of water are available in the surrounding air mass. The system captures this atmospheric moisture, conditions it, and recirculates it through the cooling towers, the heat exchanger train, and all process water requirements. There are no water intake pipelines. No water treatment facilities required from outside. No discharge to rivers, aquifers, or municipal systems. No water pollution of any kind. The system processes its own water, on-site, from the air itself. In a world where water scarcity is becoming a critical barrier to industrial development, especially in remote and arid regions where stranded gas is most commonly found, this is not a minor feature. This is a fundamental competitive advantage. No pipelines. No permits. No pollution. Just product. The economics of the ICMEP platform are unlike anything else in the energy sector. Total capital investment, $88 million. Annual revenue, $542 million. Annual operating cost, $12.5 million. That is a net operating margin of over $530 million per year on an $88 million investment. The internal rate of return exceeds 40%, nearly 3 times the typical energy industry hurdle rate. Net present value turns positive before the end of year 3. At full operational rate, the platform pays back its entire capital investment in under 6 months of operation. No other technology in the midstream energy sector, or frankly in any energy sector, delivers returns at this level. This is why the ICMEP platform is not just a good investment. It is the most compelling investment opportunity in energy today. Every claim in this presentation is backed by real engineering. Here are the actual certified specifications for the 3-plate heat exchangers at the heart of the ICMEP Cascade fractionation system. Stage 1, propane recovery. The B500 Thanks 166 condenser. Refrigerant R290, pure propane. 250 U.S. refrigeration tons of heat transfer capacity. 166 plates. 528 square feet of heat transfer surface area. Coolant, propylene glycol water, 20%. Stage 2, isobutane recovery. The B500 TMX 158 condenser. Refrigerant R600A, isobutane. 250 U.S. refrigeration tons. 158 plates. 502 square feet. Same propylene glycol cooling loop, confirming the shared cooling tower design. Stage 3, pentane recovery. The B500 TMX 94 condenser. Refrigerant R601, pentane. 125 U.S. refrigeration tons. 94 plates. 296 square feet. All 3 units operate countercurrent flow. All 3 share the same propylene glycol cooling loop. Total installed capacity, 750 US refrigeration tons. Total heat transfer surface, 1,326 square feet. Due to proprietary restrictions, some pressure and temperature values shown have been altered from the original quotation. These are not estimated figures. These are not theoretical projections. These are certified manufacturer specifications, stamped, documented, and ready for deployment. This is what separates the ICMEP platform from every other concept in the market. Real hardware. Real data. Real performance. The energy transition is happening, with or without you. The question is whether you will be leading it or watching from the sidelines. The ICMEP platform is commercially ready. The engineering is complete. The economics are proven. We are actively seeking strategic partners, licensees, and project investors who understand that the future of energy belongs to those who capture every molecule of value and waste nothing. If you are a gas producer sitting on stranded assets, if you are an investor looking for the highest return energy project of this decade, if you are an engineering company ready to deploy the most advanced gas processing platform ever built, we want to hear from you. Call 780-200-6856. That is 780-200-6856. This is your invitation to be part of something that changes the industry forever. The Cascade gas fractionation system. The ICMEP platform. The future of stranded gas monetization, built today.